Thank you so much for being here for the 2025 Emerging Media Lab Showcase. We're always so incredibly proud of the work that the students and staff and faculty come together to do to support innovation at the University of British Columbia. I'm always so delighted to be able to come and support in a small way to help present the showcase. My name is Catherine Gretzinger, and I'm here on behalf of the School of Journalism, Writing and Media, but mostly I'm here because Saeed is my buddy, and when he asks me if I'll do things to help out, I always say yes. So thank you for having me. Thank you for gathering with us on the ancestral, unceded, and traditional territories of the Musqueam peoples. People have lived and worked on these territories for millennia, and we do so ourselves, gather at the whim and at the support of Musqueam people who allow us to participate in this space. We're podcasting, broadcasting, sharing today this showcase. So wherever you are, on whatever territories you might find yourself, I just invite you to pause for a moment and reflect on the first peoples who use these lands and territories, and to appreciate and acknowledge how fortunate we are to be able to gather together today. Thank you. It is such an honor to be able to welcome Simon Bates to the podium right off the bat. Simon is somebody who has had a profound impact on teaching and learning at this university, deeply committed to technologies and innovative uses of technologies in his teaching and learning. He is the Vice Provost and Associate Vice President of Teaching and Learning at UBC, and I'm going to hand the microphone to him, wearing a pink shirt just for you.
Good afternoon, everyone. Thank you, Catherine. I'd love to say the pink was deliberate, but it was the first thing in the closet that I saw this morning. So, look, let me welcome everyone to this EML showcase as well. It's a real pleasure to be able to not just introduce the event and kick it off, but to spend some time with you. I unfortunately can't stay for the whole time, but I'll see the initial presentations. I don't really need to say this to everyone, because you're all here because you know what the EML is. You know that it's an experimental innovation hub for the university where faculty, students, and I'm going to say something else just to students towards the end, faculty, students, and staff collaborate in engaging in rapid prototyping and development of techniques to solve problems in teaching, learning, and research with emerging technologies and immersive media. One of the most gratifying things to see is how this showcase highlights projects from really diverse disciplines. This is not just a tech thing, but these projects tackle unique challenges led by faculty members and the teams at the EML that support them. All of the projects presented today are success stories, but some have demonstrated success by, after completing development proof of concept work within the EML, they've gone out and they've received funding through competitive processes at UBC. The Teaching and Learning Enhancement Fund is an annual fund at UBC Vancouver that it's getting increasingly hard to get funding for, because the quality of submissions improves every year. And I chair the adjudication committee for that, and I have to say we leave many good ideas unfunded each year because we don't have as much budget as we would like. So those EML projects that compete in that space and get funding and come back to EML for development of their minimal viable products, their MVPs, are really, really worth celebrating. And there's 2 or 3 of those today. The Procedural Poetry Funhouse, that got funding from the TLEF as part of a special call around use of AI tools. The Nurse Practitioner VR tool, and this is probably the greatest acronym that I've heard. Augmented Reality Assisting Standard Operating Procedure, ARASOP, which is what it says. Congratulations. 6-letter acronyms are, like, we like our acronyms at UBC. Anyone? Oh, well, It's still, no, I'll give you 6, right? Anyone can do a 4-letter acronym, but 6 is kind of pushing the boundary. And other, here's another 6-letter acronym, EARSIM, Enhanced Auditory Reality Simulation for Improved Mapping. Another EML project presented results at the ACM SIGGRAPH conference, a major international conference in computer science this year. I have one other thing to say. One of the nicest things about the EML is the way that it utilizes the incredible talents of our students as change agents within our academic work, whether that's teaching, learning, and research as well. And it's even easier to address many of the students because they're all wearing the same fantastic t-shirts. But my message to students is keep doing this, keep pushing to be active agents in your own education, in your own intellectual development. At UBC, you are very much equal members of these teams. You challenge the faculty and the staff, and I would even go to say as inspire them as well in the collaborative work that we do. So really heartening to see how, in many ways, with no disrespect to the faculty and staff, the EML is a place for students. Okay, you have heard enough from me. It's time to move on to some project presentations, including all of those acronyms. So once again, thank you for spending your time this afternoon at this event. Thank you for showing your support for the EML, and I'm looking forward to seeing the presentations. Thank you.
Nobody would be sad to leave their phone behind for a few minutes, but you've got to keep yours. We are now going to turn our attention to the projects and the people behind them, most importantly. And after each one of these presentations, we're going to summarize. We've got a big special award to give out at the end of our hour. And then we'll invite you to move next door, just sort of around the corridor here, and pop in and put your hands on some of these projects and let the students lead you through some of their thinking and some of the work that they've been doing. So really great time to not just think about and appreciate the projects, but actually understand how they work functionally. So that's a great part of these EML presentations. So I'm now going to go through 6 projects and invite students to come forward and make a presentation. And I'm going to begin with the Love Loop, the Immersive Fertility Awareness Training Tool. It's an immersive tool that uses 3D modeling and animation to transfer knowledge about fertility and symptothermal methods for family planning. And it was done through the Department of Family Practice under the supervision of Dr. Farah Schroff. And Dr. Schroff is not able to be with us today, but the students are going to come and talk about the project and share her presentation. So please come on up.
Hello, everyone. We are the team behind Love Loop, and we're very excited to present what we've been up to for the past term. So this is Love Loop, an immersive fertility awareness training tool. I'm Naomi Ng. I'm the team lead and one of the designers.
I'm Billy Wong. I'm one of the developers.
And there are 2 others on our team, Shivangi and Ipram, who couldn't be here today. And we were led by our principal investigator, Dr. Farah Schroff, who also unfortunately couldn't be here today. But she did prepare a video, which I will play right now.
Hi, I'm Dr. Farah Schroff. Did you know that there was a form of birth control that could also be used to encourage pregnancy? And that this same form of fertility planning could be used without any side effects? And even more, that this method is scientifically validated and is about as effective as the pill, the IUD, and other forms of birth control. The only problem is that practically nobody knows about it. It's called the symptothermal method, and it relies on 3 indicators: cervical mucus, cervical os changes, and basal body temperature. I'm designing a course so that more people can learn about this method, and it was lovely to have the EML to try to help us do some graphics for it. We asked EML to do a day in the life of a stretchy couple. So we asked them to do a beginning at the doctor's office when the doctor was telling the patients who are a couple, congratulations on using STM. It's an effective method, a natural method, one that you can use if you don't want to have a baby, and then you can change your mind and be ready for having a baby. And it's the exact same technique because all you're doing is identifying the ovulatory window. It's a technique that encourages communication between couples and perhaps encourages more equality and equity in fertility planning between couples, and it's also sustainable and ecological because it doesn't use any packaging or shipping stuff. So this is the symptothermal method, and I am Farah Shroff.
So LoveLoop is meant to be used within the midwifery program, whose students come from a wide range of ages, ethnic backgrounds, and can sometimes use remote learning. Because of this, we decided to go with a 3D desktop application game, which is widely accessible over something using VR or AR. So our project follows an interactive day-in-the-life routine of a couple practicing the symptothermal method. Each of the 3 core techniques, which are the basal body temperature check, cervical mucus, and cervical position check, are featured as core interaction opportunities, allowing users to see the actual changes to the body over the menstrual cycle. In the hopes of empowering a wide range of audiences with reproductive knowledge and power, this program aims to increase accessibility by being culturally inclusive, narrative-based, visual appealing, and user-friendly. For our user flow, our user starts with the main menu, where they can have the option to follow a quick tutorial that we made that will let them be familiar with desktop navigation controls. After that, they will enter the main game loop, where there's a clinic animation scene, followed by the main game loop, which is a circle of learning, exploring, and interacting. After that, they will trigger a hidden ending sequence, which will then end the game. So again, these are the 3 core features that our PI really wanted us to highlight, and lots of effort was put into these 3 interaction opportunities. For our design, our design was led by custom mood boards and style guides that were created to aid us in the visual design of our 3D scenes and UI. Our goal was to evoke the emotions of confidence, trust, and comfort, while also adhering to motifs of South Asian design that our PI wanted us to follow. Due to the exploratory nature of our game, we also created several user interaction panels that will pop up periodically throughout the game to guide the user in completing their goals. Several custom environments were created for this game. There is the main house, which includes a living room, bathroom, and bedroom. These were all modeled within Unreal Engine, and a 3D environment for the doctor's clinic scene. We decided to use metahuman avatars to increase the sense of immersion so that we could have a realistic game.
Welcome to the
Here's a
Love
sample of the
Fertility
lip sync
Clinic.
animations.
Tell me a bit about yourselves and what brings you in today.
My name is Priya, and this is my husband Dev.
In order to bring this project to life in an actual simulative environment, we decided to implement a number of systems in Unreal Engine 5.5.4, with the first one being the inventory system. Because of the nature it's a game, we want to have objects to be movable in the environment. So the first thing we decided to do is create this inventory system where a player can actually gather objects in the scene and bring them to the locations and interact with different characters. And to also help users of diverse backgrounds and experience in emerging technology, we've also developed a tutorial system where the user can gain a hands-on experience on learning all the keyboard controls, as well as learning some of the dynamic features that we created in the game. And as our PI just mentioned, we really want to deliver these 3 core features in our game as well, with the first one being the basal body temperature. As you can see, we've created an inspection system where an object can be placed on a panel and the user will have the freedom to move around it through the slider. As you can see, the slider, as you move around the slider over the ovulation cycle, The temperature will also change accordingly, which represents the average basal body temperature at a specific period in time. The second core feature that we aim to deliver is the cervical position changes. Again, we have an interactive slider as well as an information panel which shows the related information about the cervical position changes. And as you can see, the model is changing dynamically as we move these interactive elements. The last one is the cervical mucus position, the cervical mucus. So as we change throughout the environment, this model simulates the change into viscosity, color, and the different other biological signals that may appear in the cervical mucus. And as you can see, we have a panel showcasing all of these information, and combining those three biological signals, we can make decisions about family planning and other kinds of just increased overall body awareness in general. And besides these, we've also created other features to make the game more fun. Although it's not being specifically touched on in the slides, we have actually created a hidden path in our game. So by unlocking different features and interactions in the scene, the user will be able to find a hidden ending, which we hope that significantly increases the user experience and overall spread the awareness of family planning using the methods of STM.
For our future plans, there are three main areas we want to touch on. So for gamification, we want to establish an intent and a journey for the user, as well as add some sort of competitive edge, such as points, a reward system, or a quiz at the end. We also want the users to have more control over the game, so have different game modes and settings panels. Lastly, for interaction, we would like to streamline the game a little bit more so that the users can have more flow. Currently, the clinic scene is one long animation. It would be nice for users to speed that up to learn at their own speed. We would also love to flesh out the storyline and add dialogue during the main game. And that is Love Loop. Thank you for listening.
Terrific. Thank you very much. These guys will be next door to answer any of your questions, but is there one takeaway from going on this journey and working together to try to bring Love Loop to life that you would like to share with the room?
Do you have anything to share?
I guess I would say that this topic is obviously pretty, I would say, an unconventional one, especially for something within emerging media. So it was really nice to be able to work with the PI and her team and to break down some of our own personal barriers. We all became very close as a team, which was really nice, and it was really fun to be working on something kind of unconventional, but fun.
Yeah, and I think throughout this journey, we understand that the notion STM sometimes can be a confusing, abstract, and intimidating concept for a lot of people. So rather than showcasing using static diagrams or text, we decided to bring this to life through an immersive experience, and I think that is really meaningful throughout this experience.
You must be very proud. Thank you. Congratulations. Terrific. All right, our second presentation is Immersive Education in Mining, an AR/VR tool that uses interactive 3D visualization to simulate a site visit for mining students. It was supervised in the Faculty of Applied Science in the Norman B. Keevil Institute of Mining Engineering, and it was supervised by Tanya Welsh as an Associate Professor of Teaching. So could the team please come forward and talk about the mining project?
And I don't see my team. Where's my team? There they are. Okay. Hi, everyone. I'm Tanya Welch. I am not an associate professor yet. I'm an assistant professor of teaching in mining engineering. Hopefully with, work like this, soon to be associate. Exactly. And one of the really unique challenges that we have in teaching mining engineering is that all of our sites are remote and far away. And so this results in a lot of challenges. For example, it's very expensive to get students to site. It takes a long time to get students to site. And there are a lot of health and safety challenges when students do get on site. At the same time, there's lots of very important reasons why we need to have students go to site, and two big ones are the scope of operations. We find that when students actually go to site and understand the size of operations that we're talking about, it puts things into perspective for them, for their future learning, and also the complex interactions that happen on mine sites. So we decided to work with this wonderful team over here to create a virtual reality experience where students, without actually going to site, can go and experience some of these things, such as the big scope and the giant sizes of these pieces of equipment, as well as all of the different interactions that happen on these sites. In general, our goal is that we want to expand this out. So you'll see that right now the students have focused on one particular piece of the mine site, which is the mineral processing plant. So once rock gets out of the ground, it goes to the mineral processing plant so that it can, there's things that get done to it so that eventually we can get the valuable mineral out of the rock. But we also have things like the tailings dams on site. We want students to understand the environmental impacts that can come from those dams, as well as the open pits and underground workings. The other thing I just want to touch on, and it is a little bit sad, but I mentioned the health and safety challenges of our students going to these sites, and actually while the students were working on this over the summer, there was news out of China where a group of students in mining engineering went to a site very, very similar to how our students go to these sites, and while they were touring the mill, which is exactly the part that these students have developed in VR and that you guys will get to see in a second, there was an accident where some railings ended up collapsing and 6 students ended up losing their lives. So I think that it's very, very exciting that through technology such as this, we can take that risk entirely out of the picture for our students. And with that, I will hand it off to our team.
Hello, everyone. We are the Immersive Education in Mining team. My name is Kai. This is James. We're the developers. This is Chenyu and Nikita, our designers, and of course our PI, Tonya, and then our subject matter experts, Gonzalo and Pablo. So, okay, just for a little bit of context, this is the mining site itself. It's kind of split into these 3 different areas. So we have the pit where these raw ores are extracted from the earth, and then they come into the mineral processing plant where like the valuable things are separated from the waste, and the waste goes back into the tailing. So due to the scope of our project, we are just going to be focusing on this part in particular, which is the mineral processing plant. So as Tonya was mentioning, this is a place where mining and engineering students come visit to kind of see the scale and the operations in real life. But there are a couple issues, of course, the accessibility concerns. This is a very remote environment, as well as the safety, as Tonya mentioned.
So yeah, based on these challenges, the project is created to create like an interactive and immersive learning environment for the students to explore a virtual mineral processing facility. So they can explore various mining machines, learn about the roles of the overall mineral processing workflow. So in the current state of the projects, we built 3 available areas. First is the milling area, next are the hydrocyclones, and a crushing site.
Yeah, so this is our current user flow showing how a user will move through the app. First, they'll see the map selection region, which is the topo model of the entire mine site. Then they can choose to go through an onboarding tutorial, especially if they're unfamiliar with VR, and learn about the controls. Then using the flags on the topo map, they can teleport to the site. And once they're in the site, they can move around freely and explore the machines. There are control panels through which they can interact with the machines and also learn about the machines through text and watching videos. Now, they can open their wrist menu and start a quiz mode. So now they can test what they just learned so far by answering multiple choice questions based on the machines in the area they're in. Using the same wrist menu, they can open the 2D flowchart of the entire mine process. This can also be used to teleport to certain machines so that there's a more immersive experience than just looking at the 2D picture.
Yeah, so navigation. Looking back at this flowchart, these first three are what we call the navigation segments. So our map selection is kind of, we have this whole mine site. Where exactly do you want to be at this mine site? And of course, for our project, there's only the mineral processing plant, but in the future, it will be expanded. And then also an optional tutorial, as Nikita mentioned. Yeah, the way we implemented the map selection is from this topological map. So this kind of represents or is actually the topology of the mining site. So you kind of can click on these flags to zoom into specific areas where you want on the mine site, and eventually you will zoom in to the place you want to be, which is maybe the mineral processing plant or any other area.
Another system that we built in the topological site itself is the tutorial system, so that the users can know how to use the topological module and navigate through them, as well as the controls that they can use once they actually enter a section of the processing plant.
Yeah, okay, so once we've used this map selection to get into the mineral processing plant itself, we can actually travel within it as well. So this is the flow chart. So it kind of serves two purposes. The first is, well, of course, it's a flow chart. So the part that is green is actually depends on where you're standing in the mineral processing plant itself, and it'll highlight that part on the flow chart. And secondly, we can use it as navigation. So you can click on any of the available parts on the flow chart, and it'll teleport you in the virtual processing plant to that part that's related to it.
So now we're going to talk about some features in our applications. Back to our user flow chart, and once users finish their onboarding tutorial and map selections, they can actually get into the site. And in the mineral processing plant, user can see the conveyor belt, which simulate material flows of the site. And from the left image, you can see the conveyor belt carries rocks and materials from the main storage to SAG mill. And from the right image, you can see the feed box and the pipes, visible pipes that shows the fluid and the slurry through the entire system.
So now for the main areas of the level composition, which are the mining or the machineries and equipment regions, where we're also going to discuss interaction and information systems. So as I mentioned earlier, here are the machineries and equipment that the project currently has: the milling areas, the crushing area, as well as the hydrocyclones, all of which can be traversed through the flowchart.
Yeah, so a bit on the interaction of these machines themselves. So we kind of have two main sources of interaction so far. The first would simply just be the rotation rate at which these machines go at. So you can kind of tweak that how you want. And secondly is a transparency function. So you can make the outer parts of these machines transparent to see what's going on inside them, which is actually an advantage over to doing this, of course, in real life, because you wouldn't be able to do that. And for different machines, you can for different machines that have multiple layers of transparency, you can go outer, inner, and the most transparent, as you can see on the right side there.
So another feature that we added are the information panels. These are embedded near most of the interactable machines, just to provide more context about what they do, as well as like a video, so that they can show like other visual aspects of the machines itself.
Yeah, so once you get a bunch of information from these machines, there should be a way to test yourself, which is what we call this quiz system. So this is kind of a multiple choice quiz about these machines that you can open up anywhere at any time. So this is to encourage reinforcement learning. So maybe you can first look at all these machines and their info and then test yourself to see if you really learned it. Or another way you can do it is first take the quiz and find your knowledge gaps and then kind of look around for the information that you missed.
For future considerations, all those features we talked about before bring us to the current state of our project, and but we think we have more opportunity to improve on. We've shown the frameworks, how the frameworks create immersive learning environment for students, but there's a few points we would like to improve. First is we would like to expand the framework so developers can build more levels across industrial sites and reusing existing assets, also incorporating higher fidelity visuals. And eventually, more gamification elements is also very important for students learning mining knowledge because, for example, like quiz mode. So we would like to import into the more like elements like that. And that's all the future consideration we would like to talk about. Yeah. Thank you so much.
So, big team working with a strong lead. What was the biggest challenge in pulling this together in a short period of time? Who wants to?
Maybe one thing was just the complexity of the mineral processing plant itself. Like, it's a very, very complex system that is not easy to model, and you need a lot of information and specifications from our subject matter experts to do it. So that's one thing that surprised me, as well as just the scale of the mineral processing plant itself. Seeing in VR was something that was really interesting.
I will agree with that because I think that the components of the entire facility inside is very difficult because like you can not change anything. And you need to make sure like this function and the system is working. Even I was in architecture major, so I think that's quite difficult to me as well. So yeah, that's a big challenge for me.
Good stuff. Thank you very much. Don't forget, when you're working in high fidelity, sound would change the experience fundamentally. And working on a mine site, it's loud. So having people navigate through their thinking and processing with sound in the background would really change the game too. Congratulations. Thank you. Okay. All right. It's fantastic. One thing I do want to point out, this has been a very busy summer at the EML. There were 16 separate student projects happening. People were working and collaborating all together and working across discipline. So this is one of those rare opportunities where, you know, we work in silos at universities. The silos are broken down and people come together and share their knowledge and create amazing things. So congratulations to all of you. I would now like to invite the Nurse Practitioner VR Tool team to step forward. This is a tool for student nurse practitioners to practice communication and clinical decision-making skills. It came through UBC Nursing, and it was supervised by an associate professor, Ashley Scott, a professor of teaching in the Faculty of Applied Science. She sends in regrets today, but she's written up a memo that I'd like to share with you. The Nurse Practitioner Project began with a very real problem: how to create more accessible, engaging, and effective ways for students to prepare for high-stakes clinical assessments, and how to best prepare them for the complexities of clinical practice. Over time, with the support of the EML, this idea has evolved through the hard work of many different teams, each bringing with them new insights and expertise. So I'm going to hand it now to some of those experts right here beside me.
Thank you so much.
Good afternoon, everyone. So we're here to present Nurse Practitioner, a VR tool. And first and foremost, let's go behind on who's part of the team. So our principal investigator, as Catherine mentioned, is Ash. And who's part of our team? We have Pedram over here, one of the developers. Myself, Radima, also one of the developers. And Toby, who's one of our designers. So what is Nurse Practitioner actually? So Nurse Practitioner, it provides an immersive experience for nursing students, which simulates an OSCE examination, which is a nursing exam that all students have to take, and it includes things interacting with lifelike metahuman patient avatars, an evaluation system that also follows the OSCE rubric, and this project was developed in Unreal Engine 5.5, and as well, this project has been part of EML for quite a while, so it's one of our most viable products. So overall, this project, it provides a solution for students to have a more hands-on and immersive experience, as well as provides a more immediate feedback so they can develop their skills faster and much better. Over here on the slide, you can see our user flow diagram. So first off, the nursing student, they are able to go to our menu, and they're able to select one of our 6 scenario options that we have here. And once they select one of the scenarios, they kind of go into a cycle of asking the metahuman avatar a question, the avatar responding back, and once again, asking questions again. Really, overall mimics like a clinical-like environment. Afterwards, they're able to evaluate their current session, and we are able to provide pretty much a grade, sort of, which follows the OSCE rubric and on how they would be graded if this was a real-life OSCE scenario. And this is a quick gameplay of on how Nurse Practitioner is.
Hello, George. How are you doing today? Not too well, honestly. Been more forgetful lately. Do you have a history of allergies? Nope, none that I know of.
And yes, as you can tell, this was done at 2 times the speed just for the sake of time. Going over to design.
So now I'll talk about the animations in our project. Our goal is to make the patients realistic. So the movements had to be really both believable and natural. Let's take a look at the characters. We designed 6 patient characters and 1 examiner. Each has unique traits and behaviors, covering different medical scenarios, and this really gives us a broad range of cases to work with. Now let's take a look at our animation process. Since we built and modeled all the MetaHuman characters in MetaHuman Creator, which came with rigs, I didn't have to rig all the characters. So I basically just hand-keyed all the animation sequences, like 6 idle animations and 3 talking animations across all the patients for efficiency. This workflow was a bit tricky, but it gave us more control. We also added this...
Nope, none that I know of.
Yep. We also added this amazing plugin called Runtime Lip Syncing. You can see how now the mouth movement really matches the speech, and this is really making our interaction super immersive. Now I'm passing over to Pedro.
Now I would like to focus on some of the UI UX elements that we implemented this year. Basically, these 2 on the top came from the previous iterations, but we made various improvements to make them more appropriate for an MVP project. Moreover, we also ported the patient situation UI from the previous term, but we also improved it as well as we could. We added 2 new UIs. One of them is a recording UI, which would indicate when the user is actually speaking, and the other UI is the speaking UI, which would indicate when the MetaHuman itself is speaking or generating answers. Now, we also have the development part. We made great efforts to completely rewrite the code base, and before, if you can see, the code base was somewhat loosely structured. It was also a little bit cluttered. We made great efforts to completely rewrite it and to basically make it a lot cleaner, more readable, and more performant, unlike its previous iterations. And now for MetaHuman AI prompt design, I'll pass it back to Radima.
So this portion is for the MetaHuman to be able to communicate with the nursing student. So we had an AI, kind of like an AI backhand on here. So first of all, we told the model who they were. So in this case, they're a patient. Then we kind of set up a backstory, like what brought the patient to the clinic today, some vitals, their past medical history. Afterwards, we added some behavioral and conversational guidelines, such as how long they're supposed to be speaking for, how much they're actually able to share so they don't expose everything, like what's wrong with them, at once. And then we had some guardrails and role consistency, such as making sure that the AI model doesn't hallucinate or doesn't expose that it's an AI or a simulation in any sort of way. Passing it on to...
So there are certain future considerations that we all still want to make. One of them is a more holistic evaluation. Right now, the way that our evaluation system works is purely based on the user's responses. But we are also planning, just like a real OSCE, to also potentially evaluate on what the patient has to say in case they let on anything that they shouldn't have. Also, there are some aliasing issues, which are some of the limitations with the technology that we have right now. We are hoping that future teams can address those issues as VR technology improves. And finally, we are also planning to add a little bit of a more natural animations for more immersiveness in the program. And if you have any questions, we will be more than happy to answer them in the Dodson room. Thank you, everyone.
Just before I let you go, Ashley in her note also wrote, the current team has done an incredible job of further refining the simulation. Please listen as they share exactly what they've been doing to move this work forward to a polished MVP, minimum viable product, and tool that is now almost ready to be evaluated through research and feels very close to being ready to go into a classroom. What's that like for all of you to know that this simulation, this thing that you've been building, is actually very close to being in a classroom and being used IRL for teaching and learning?
We are very much excited because we're glad to have worked on a project that is finally making it into people's hands, and more importantly, it has the potential to actually help students, which is kind of one of the goals, to help them better prepare for their OSCE exam, and be less stressful for the real thing. So we're glad to have made something that has the potential to truly help people.
Congratulations. Thank you so much. We're just going to flip the order of things a tiny bit here for you and invite one of those 6-digit acronym teams up. EarSim, a virtual reality tool that helps people who are hard of hearing improve their sound localization ability through the School of Audiology and Speech Sciences. And this is a prize-winning project. So I'm just going to hand it straight over to who? Who's taking the reign? To Walter, over to you.
Thank you. Hi, everybody. My name is Walter Ciocca. I'm a faculty member of the School of Audiology and Speech Sciences, and I am very happy and proud to be here with the project team for them to show what they have achieved during the past year. We all know that localizing sound in the environment is very important. And particularly when people start losing their hearing because of a number of reasons, we know that localization ability decreases, sometimes substantially. We also know that localization is used for recognizing speech in noisy environments. So in spite of all this, we realized that there are no standardized clinical tools for assessing localization abilities that can be used by audiologists or hearing health professionals. And there are no tools that are widely used for training localization abilities. So that was the reason why we decided to try and see if we could fill that gap. The requirements that we set to the team were very high, I think. It was to build realistic environments that could be used in a gamified context to both assess localization abilities and use the app to train localization abilities. And this tool has now been developed far enough so that during the summer we made relatively minor modifications so that we can start collecting data. So it's going to be used for research purposes, we hope, very soon. And eventually we hope that it will be useful for clinical purposes and also for training our own students in the classroom. So thumbs up and cheers for the team, and they can tell you the wonderful things that they were able to do.
Well, thank you so much, Walter, and let's give it a round of applause for introducing this project. I'd like to welcome the team. A lot more people than just us have gone into building EarSim. We'd like to talk about Dr. Doug and Dr. Joanne, as well as Eli, and their contributions and their expertise, and along with the staff team, Frederick and Mohsen, for their guidance in kind of how to develop this. And I would like to introduce the team, Mark, Eric, Cindy, and James. So a bit more of the context about why EarSim was developed is that they really had this antiquated system previously, where you'd go into this room, there'd be speakers set up all around you, and you would have to correctly identify which speaker the sound came from, and that was your localization assessment. So localization is incredibly important. You want to know if there's a bus coming from your right, and many other experiences like that. If you're at a loud dinner table, who's speaking to you? So actually, what is EarSim? It's a VR-based training and assessment tool that uses spatial audio and procedural generated environments to create kind of tests for localization so people can train and researchers can capture that information and do research on it. So a bit of the user flow is that it starts with you put on the headset, as all VR applications do, and then you launch the application, and you're in this kind of blue space with a menu, and you can tweak some parameters, choose your difficulty, and then you go on to choose your environment, which you're in, where you'll be actually identifying the sounds in, and then you go through a series of tasks where a sound comes from a certain location, and you identify that sound, and your score is captured based on your accuracy of identifying the sound, and at the end you are given a summary of your results for improvement and for the research purposes. So now I'll be giving it to Mark to talk more about the gameplay and calibration.
Thank you, Julian. Yeah, so when the users start a round, they spawn into this natural environment where they have to identify this animal. They start with seeing a progress panel, which tells them the current allotted time and their current target. After they identify it, they receive a score and an update about their progress. The users can pick from a variety of maps. There's a desert, a mountain, and a forest. All that can be customized and have a variety of difficulties. The difficulty settings can be customized. This changes how the maps look and how hard they are. The parameters that they can change include the distance, which is how far away the animal is from the user, the clutter, which changes the scene and the placement of objects and the density of them, the noise, which is the background noise, and also the weather effects, and the darkness, which changes how easy it is to see the animal and forces the user to rely on the auditory cues.
In terms of the UI features that we developed for the user immersing, we have a tutorial level where the player can go through the tutorial and basically teaches them how to use all the VR controls and how to use the core gameplay mechanisms. We also have a progress panel, which helps the user to get feedback while they're playing the game. Basically shows them how many seconds they left to point to the next animal, and also what animal they're pointing to for this round.
So there's also a pause menu to allow for users to basically pause whenever they want. Yeah, and then a feedback panel that provides like the analysis of user scores and overall performance, and then this allows users to improve over time as they use this application. And then to ensure that we have optimal user experience, we also conducted a usability test. And the main goals of this test was to determine usability issues, identify missing features, and to confirm smooth user experience. And then we had a mix of participants with varying VR experience and hearing abilities, and our results were actually really positive. A lot of our users thought that the application was very intuitive to use, and the environmental difficulty level was also really appropriate. And then the sound environment from like the distance and directions was also, it felt really realistic.
Thank you, Cindy. So now that we know the core features of the application as well as the preliminary feedback that we got, like we wanted to streamline the experiments, as Walter mentioned, to collect data and to process like batch of experiments. So I'll be telling about the extensions of those. So this is the current user flow for the where the users are doing the parameter calibrations themselves. We wanted to get that outside, make it optional for the users to calibrate, and have external users such as researchers to set up the experiments and batch them. We also want to retrieve the results so that they can analyze them. So with that in mind, we wanted to implement an external data system where the data system writes the conditions, the experiments, as well as the current session, since we wanted to use this in real time to set up like which session or which experiment is going to be simulated in the VR application. The VR application will write the results for the data system to be read. So this is a tool that we built. I'm not really gonna explain all of these, but there are three main parts. First is the experiment dashboard, which they can calibrate the experiments. The library, which has the trial pools, the participants, and all the data, as well as the configuration settings that they can set up the current session, they can read the results, they can reload the session. So now, instead of in the menu where the users can calibrate the parameters itself, the researchers can create these experiments with their own, with additional helpers such as knowing where the sunlight directions are, as well as the metrics for the audio that they wanted to play or simulate for the target or the background noise. So here's a demo where the researchers are using this GUI in real time while the participant is playing the application. So here, the researcher is changing the experiment, what experiment they're going to use, which participant is going to do it, and which blocks are going to be tested. So now once they set the session, the user just have to click the reload data, and they don't have to calibrate anything else, and just proceed to the application itself. So once that's done, it's the original gameplay where they will be provided a feedback panel. Then they will have to locate where the sound sources are. Then now since we're batching it, we are like generating different trials in the same block. And every trial, they have to rotate to the original position because we wanted to make it as accurate as possible. Once that's done, they're gonna have a list of trials, the result of them. And once they exit, the researcher can just click reload results. And once they reload the results, they will have it there, which they can export as a JSON file or a CSV file for future analysis.
Okay, thank you, James, for the demo. So for future improvements of this project, one thing that we can do is to improve the user experience, such as improving the tutorial level, improving the accessibility for the game. And also one thing that we're planning to do is to implement data saving for a profile. So we already have a data saving system, but we're planning to use that to add more profiles for different users. And also one thing that we can do is to increase the number of annual avatars to increase the variety of annual for more immersive experience for the game. Yeah, so thank you so much.
So these are all interesting next steps. Think big for a second. How far could this go? What could you do with this kind of a project? And how could it be extended into other disciplines, other kinds of projects?
I can talk a bit more about how this project came to be. And Eli was very instrumental in this because he lives in Vancouver Island, very far. And he wants access to this kind of research, benchmarking, so that he can get his ears checked up because he is unilaterally deaf. And he wanted to kind of gain access to that. So really enabling access to people who are out there in the wild and they need access to these kind of benchmarking and these kind of systems, and that's kind of where I see this going.
It's amazing. So you can change lives with technologies. Wonderful. Congratulations. Well done. Well done. Oh, okay. We have one project and then another project that we're going to do. So we're going to put a little pressure on you guys. ARA SOP, we're back to one of the 6-letter acronyms, an augmented reality tool that supports the teaching of safety procedures to students using tools at the Center for Advanced Word Processing. It's supervised by Jorn Detmer, an assistant professor of teaching, wood products design and manufacturing in the Department of Wood Science in the Faculty of Forestry. Hi.
I'll keep it really short. Can you all hear me? Yeah. I took 3 bullet points here. ARA SOP. It's not AR. We have a problem. Apparently, it's actually MR, which is mixed reality. So I'm still learning a lot. The other one is students are the driving force, and I think that's been said many times here. But that is what I'm most excited about in this project. It's just really, I mean, you're driving all this, and it's just so much fun to work with the different teams, and yeah, super stoked. Last one, well, I think you talk about it a little more. This is the second phase. I think it was mentioned, so we did. I think we're hopefully past the MVP. Are we past the MVP? I think so. No, so we did the initial, is this going to work? In my opinion, 100%. And so the second phase now, I applied for TLEF and got that. And so the second phase is supported by TLEF. And so standard operating procedure, technical learning, technical hands-on learning, really just to supplement the in-person and instructor-led learning, self-paced learning, lots of things I think this really makes sense for. So I'll let you take it away. Thank you.
All right, thank you, Jorn, for introducing the project a little and for his kind words. So this is AR-ASOP's team. You've met Jorn already. My name is Alvin. This is Richard, and this is Julian. As well, we want to give a shout out to the previous team who helped create this project into life, and that's Walker, who's in the audience there, as well as Kai, who you've met on the mining team so far. So the project overview is essentially what Jorn sort of mentioned. It's to help students self-learn, self-pace their learning while they're working on a lot of the forestry machines. And these are students who have a little bit of experience. They're definitely forestry students, unlike me. You know, I'm not going in there just to work on those machines. Well, I've got permission from the faculty member, but these are people who have got a little bit of guidance and now want to review or want to then see how to maintain a machine. Perhaps they'll also explore a little bit more with this machine as well. And it's using the Apple Vision Pro. They'll have guiding virtual entities, as you see on your right, as well as the builder mode, which is something that we've implemented.
So in our proof of concept version of AR-ASOP, we made a fully implemented tutorial for the Martin T75 table saw using 3 types of entities, as well as a movable window showing instructional text and videos. We also used the Martin logo on the machine, as you can see there, for calibration and image tracking so that all the entities are placed correctly.
So now we're going to a bit of what has been improved. Okay, well, all right. Originally, we were going to make it a little bit less technical, but now we're going to have something, I guess, put all of your brain cells in. And essentially, originally, we were going to have just one machine. That was the proof of concept. And they had hard-coded data. And if you wanted to actually create a new tutorial, it would have to be done through code. Now, what has been improved is that this data is now stored on a server. As well, we have different files to represent different machines so that you can create pretty much unlimited machines limited by technology. As well, there's a new feature, which is to create these tutorials. Originally, as I mentioned, you would have to do it through code, but now anybody can go in and, using our application, can create levels like you would a video game. A little bit of an overview as to what the level creation process would be like. This is essentially being able to add in various objects. For example, the triggers over there are used to monitor your process. If you do not put your hand into that area, then you wouldn't be able to move on with your step. As well, we've made it so that we have a sort of centralized sticker so that you can put onto any different machines. It can even be, your fridge at home, or perhaps a 3D printing machine. That's sort of where we can go with this project, and it can be used for all sorts of things. For example, even in the engineering department. And one last thing is that we translated our previous table saw tutorial, which is the thing that Walker and Kai had been working on, into this new format so that people can even add on to this.
So now I'll walk you through a bit about how you would actually go about creating these tutorials. So the main step is to open a web app, and you define all your tutorial steps there. You'd add in the content and the text. So that would be text and video that would be updated, that you would be viewing in front of the machine or around the machine as you place the different panels. Once you're happy with that and you've added all your content in, you go and you put on the Apple Vision Pro, and you can choose either admin or user mode. If you only wanted to update the content, like the videos and the text, you can just go and use the tutorial. However, if you are in admin mode, you can then go and place the entities in the environment to demonstrate to the user where to look, where to be interacting with objects, and these different parameters. So this is an example of the web application going. So you can go in, you can see all the machines, you can add your steps in, and then on the left side we have what the Apple Vision Pro looks like when you're wearing it, and you see the virtual entities, and you can place them with your hands and such. So kind of how this application has grown is that where we were in May is this inner box. So we had the model, the app model, and the view. So the model is basically the data, the app model is what's holding the data, and the view is just what's displaying it. What we added was, instead of storing the model locally on the headset, we changed it so there's a web server which pulls and receives information from the Apple Vision Pro so that the tutorials are dynamic. They're not static local files on the Apple Vision Pro, and then also our static files are also hosted on the cloud so that they do not need to be uploaded, which was a significant problem we were having at the beginning. So other work we've been working on is the voiceover, new entity types, and entity fine-tuning. And for more of the future work, I'll hand it off to Richard.
So one of the things we hope to do later on is to have a more in-depth UI and UX design, as that hasn't been a focus in the project so far, as well as adding additional features and an interactive tutorial for using the Apple Vision Pro in general.
And to sort of add on to that, some other features that we could have for this would be to add even more entities, or to sort of branch out in a way that we would add something like a ghost hand. And this would be even more informative for the users to actually follow through with this guide. As well as mentioned previously in a lot of feedback, was to have like safety markers, for example. We're dealing with a lot of equipment that could be potentially dangerous even for people who are quite experienced with it and work with it day to day. And so this could be another branch that we could go into as we work on this project and as the new teams might pick this up. Oops.
Thank you for listening.
Whose idea was the ghost hand? Okay, yeah, you can tell. Yeah, congratulations. Thank you so much. Okay. Yeah. Good stuff. Thank you so much. All right, we're going to move to our last team before we make a special presentation and then head next door to allow you to put your hands on some of these projects. This is the Procedural Poetry Funhouse, a project that aims to use AI and VR to reimagine poetry as a physical space using the philosophy of play-based learning to further student understanding of poetry and the process behind it. It comes to us through the School of Creative Writing and the brilliant Jennifer Moss.
Hi, everyone. Our acronym for the Procedural Poetry Funhouse is PFF. We didn't think that through. So how many people here were terrified when they were asked to write poetry in high school or in university? Okay, yeah, common response. So in the School of Creative Writing, we're always looking for ways to demystify poetry and make it more accessible to students. So one of the ways that you can do that is you can make it about the process. And procedural poetry, which the team will explain more in depth, is a form of poetry that really emphasizes process. It's sort of the antithesis of AI, because AI is all about pressing a button and getting an easy solution. So if we're talking about large language models like ChatGPT, for example, which are, nominally threatening to creative writers like myself, because they make what I do seem easy, right? And it's not easy. It's not easy, right? Because of the process, because of the fact that real writing is connected to experience. And when you decontextualize it, you remove meaning. And so we wanted to create a way for students to engage with poetry and also respond creatively to the sort of challenge and opportunity that AI introduces into the creative writing sphere. And so that's what engendered this project, as well as an interest in Vancouver's own history as a place that basically breeds weird poets who challenge form and challenge assumptions around what makes a poem. People like Judith Copperthorne, who happens to be the aunt of a good friend of mine, a recently deceased poet from Vancouver. And so her work pops up as a theme in this project. So this team has been incredible. This is our sort of our second go. We got some TLEF funding to develop it further. It's been a series of talented, incredible people, designers and programmers who have lent their expertise, and it's been such a privilege to work with them. Austin Osworth is my teammate, and Annabelle Lyon and Bronwyn Tate, a poetry expert. And the group of us made a conscious decision to sort of challenge the students creatively, give them a bunch of input, and let them go and see what they did. And boy, did they go. And it's really neat to see what they've come up with. We're not finished. We're still going. We've got lots of plans. I have to teach in about 10 minutes. So I'm so confident in this team, I'll probably run out partway through their conversation or their presentation. Okay, so no offense.
No worries. Thank you, Jen. Let's give her a round of applause. All right, I'd like to take a moment to introduce the people who made this possible this summer, but there's a whole cast of people that are not listed here and have made significant contributions to this project, and I just want to be mindful of them. However, this is Amy, we got Jack, and Phoebe, so let's give it a round of applause for them. All right, now I'll be handing it to, oh, I forgot to mention one person. Daniel was another developer this summer who is not with us today, and we'd like to thank him for the work that he's done also. I'll be now handing it to Jack to tell us more about this project.
Yeah. Hello, everyone. Again, I don't know if I can, summarize this project much better than Jen just did for you, but I'll try my best. So the Procedural Poetry Funhouse is a VR experience that we created to, let creative writing students engage with poetry in a more immersive and fun way, make it more approachable. And yeah, in particular, we were inspired by the work of Judith Copperthorne, who, as Jen mentioned earlier, was a procedural poet based in Vancouver. Specifically, she specialized in concrete poetry, which is a more visual form of poetry. As you can see the example on the left here, the poem comes more from the visual form than necessarily the words in there. You're paying more attention to the overall than the zeros and ones that make up the big zero and the big one. But even after all that, I have to ask, do any of you actually know what procedural poetry is? Yes, no, maybe? We got one hand, okay. Maybe if I rephrase it, are any of you more familiar with blackout poetry? You guys have done the thing where, yeah, one hand. You guys have done the thing where you take like a pre-written text and you black out certain words to, leave a poem behind. And that's sort of like where we talk about how procedural poetry is defined by a process. The result of the poem comes from blacking out the words, but not necessarily choosing the perfect word. It's a process more so than anything. Yeah, pass to Amy.
Yeah. So here's some artwork by Judith Copperthorne. So these are some concrete and visual poetry. Judith really likes to challenge and experiment with the different, with the combination of art and visual elements with text. She used combined lines, drawings, and text, and make something called drawing poetry, drawing poems. So some of her central themes focus on nature, domestic environment, and domestic space and community. And because inspired by her, we decided to take on an approach of transitioning from traditional 3D models into 2D hand-drawn watercolor paintings. So most of the assets in our projects are hand-drawn watercolor, scanned, and then imported into Unreal Engine. By doing this, not only do we unify the art styles, we also reduce motion sickness and cyber sickness. Most importantly, we greatly improve the in-game performance. We also incorporate some Judith's artwork throughout the experience as hints and guide the users in a poetry environment. So next, I'm going to talk about some of the levels in the projects. So to start with, the first space that the users are spawning are the Arbutus Outdoors. This is a space inspired by the Arbutus grocery community. It is a grocery store in the late 1960s where artists collaborate together and then work in this community to share their artwork. So in this environment, the users will be introduced to the controls to navigate around the world, as well as as a moving UI element that will guide the users.
So I don't know who's used VR, but it's challenging. There's a lot of controls and it's confusing and you don't really see what's happening. So we added in this AI assistant. It's kind of serves a multi-purpose in the project. One, it kind of grounds it so that you have someone else to do the experience with. You're not alone in this big world where you don't really know what to do and the instructions are kind of unclear. And you can go and you can talk to this cat and you can say, hey, what am I doing right now? Where do I need to go? And it will answer all your questions. And we've added a lot of context awareness into the actual application so that it can be really robust in this situation. And actually where the cat kind of comes from is Judith Copperthorne herself. She had a cat named Jasmine, so it's kind of her cat showing you around the Vancouver environment and how to make procedural poetry. And these really came to life with some of the animations that our designers made. And this is another great place for improvement in the future, is adding in more animations because people seem to really enjoy interacting with the cat. So one of the main areas that you enter after the Arbutus Outdoor is the lobby. So think of this as kind of the main menu of the application. So instead of a traditional 2D environment, which we're used to for technology, this is a menu which is in 3 dimensions. So you go through a door to access a new space instead of just clicking a button. And that is kind of bringing the elements of virtual reality to life in this project and creating contextual situations which make sense to the user. Now I'll be having Jack tell you a bit about the Blackout Room.
So yeah, we talked a bit about blackout poetry earlier, and I'm going to throw a new term at you. It's called unblackout poetry. So this is actually a new form of procedural poetry that we at the EML, or I guess an earlier team, initially prototyped, where we're going to have users be creating a blackout poem, but instead of blacking out words you don't want, you're going to be highlighting the words that you do. And the reason why this distinction is really important is because we're again encouraging creative writing students to engage with an LLM and AI through resistance. So basically how the Blackout Room works is we have users go in and we give them a prompt. We're like, rant about anything you dislike. So for example, I don't like pineapples on pizza. So I'd go in there and I'd say, I really hate pineapples on pizza. And then we'd transcribe that, send it to an LLM, and the LLM is prompted to respond with something like, maybe you should embrace pineapples on pizza. Maybe pineapples on pizza isn't so bad. And it generates this word wall where the users can then go in and select certain words to create a final poem. You can see a bit of an example of this on the right by Julian here, an excellent poem, Joy, Exploring Crunch, Redefine. Yeah, and then we have some other activity rooms.
Next, we have the maze, also a procedurally generated space to encourage the users to go around and collect different word magnets. It's kind of messy and then chaotic, kind of resembles an artist's studios, and it just encourages the users to be more creative in the space. Finally, we have the attic. It is also a room inspired by the second floor of the Arbutus Grocery, where a lot of artists, poets, painters, sculptors, they used to live on the second floor and create artwork together, including Judith Copperthorne herself. So in this room, there's a common word shelf that you can collect extra word magnets. There's a music player, and you can just freely create poetry in this space.
And these are our activities, and thank you so much for listening.
Thank you so much. How many of you, other than you, Julian, we know, doing some experimenting with poetry, how many of you have been upping your poetry game since entering into this project?
Oh, definitely.
Yeah.
Yeah, no, the inspiration behind it was so exciting because then you're just pulling things, you're pushing back on AI and you're pulling ideas into poetry. So, yeah.
Yeah, I'm actually a creative writing student, so, I should be better at poetry than I am, but, this project is really encouraging me to step up my poetry game. It's just really fun to just mess around with words and place them in space and make a 3D poem.
Yeah, absolutely. Well, congratulations. Wonderful work. Okay, poetry team. Okay. Huge congratulations to everybody, faculty, staff, and students. for putting their heads together and coming up with these remarkable projects. And a big hands up to all of the people who sort of set aside their own egos and intentions to be able to make space for other people's ideas to emerge and lead. So great work collaborating, everybody. Please give yourselves a round of applause. I'd like to invite Saeed and Marianne to come up. We have a special presentation now. We want to take a moment to celebrate the memory of a former staffer at the EML, Kirk Harrison. He passed away very unexpectedly and way, 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 way too soon. And his loss a couple of years ago has really been deeply felt over this time. And we're very, very pleased to know that his family has supported the creation of an award called the Kirk Harrison Award. It recognizes students who show leadership, ingenuity, collaborative commitment, open practices, and a desire to use emerging technology for social good. And we're so delighted to announce this year's winners and acknowledge their accomplishments. This year, the award is shared by a recent graduate and 3 current UBC students. Marianne and Saeed, I think you're going to present.
Bridget, can you just ask James to come back? I think he's in there working hard on a demo. Walker, on. Victoria, can you please come up and join me here at the mic? EML is a fantastic collaborative team. And the memory of Kirk's contribution to the university, I think, is really exemplified through the efforts of these students. It has been my privilege to work with them. They work on the projects that you've seen that are incredible. But over and above that, they are very creative. They lead and they mentor others. They lift them up and they create growth and learning at the university that's irreplaceable. So you'll have an opportunity to meet them during the demos. I didn't want to take too much of your time because we want you to get over there and have a cookie and have a drink. But Victoria, On, Walker, and James, congratulations on the Harrison awarding to all of you. We appreciate what you've done for the university and in Kirk's memory. Thank you.
Okay, last word?
No, just wanted to give them awards.
This man, he'll never take the microphone. We try every year, Saeed is sort of the mastermind behind all of this stuff, so a big round of applause for Saeed Tanakar. Okay. We'll get your photos. And then we do invite everyone, once we give these folks one last round of applause. Don't be shy, folks. Get in there with your awards. There we go. All right, round of applause. Congratulations. Okay. Okay. And we do invite you next door. You can have more than one cookie. Right next door, you can lay your hands on some of these and talk to our students, faculty, and staff. Thank you so, so much for spending this time with us today.